Hi everybody, so I almost forgot to start recording here while I was working. Basically was talking to my screen for the last 10 minutes thinking I hit the button, but I didn't. So we're gonna go get into this. So what I'm working on is yesterday I implemented actual button clicking, so you could click a button and it would trigger an action and you could see that action being triggered. Now we're implementing the actual actions themselves. This comes in two parts. We're going to have an actual button click action. This is what actually handles the button click. Then we're going to have an action which handles what the entity does. The reason these are separated is we're going to have server-side logic and client-side logic, as this will be a multiplayer game, and the code for multiplayer is partially implemented as it is. I'm going to wait till I get the game more progressed before I start actually implementing multiplayer, but why I'm at it, I'm trying to keep render logic separated from server logic, or actual game logic. So we're working on game logic here. So what I'm doing is I'm setting up these action events which will be used for what the entity does. Right now the first one we're going to implement is movement. So what I'm doing here is I'm getting ready to set up a registry system where I can keep track of all the actions registered in the game. Then each entity will keep track of actions they can perform. So you will have entities that can do movement, you'll have entities that can't do movement. So like a turret can't move, but it can attack. You may have an entity that can move but can't attack because they have no weapons, or they don't know how to do hand-to-hand or something. We'll get into the details on that one later. But every action is going to be created, and then it'll be registered here. Actions have a name and they have a display name. I'll implement display name here later because it's not important at the moment, but the ID is the important one. So what I'm going to do here is I'm checking to see if we're going to override. If we're going to override, we're just going to do system.out.println action plus action map .get. Okay, so that just will tell us that we're overriding something. We're not going to stop somebody from overriding, but we're just going to put in the console that an action has been overridden, just for record keeping. You always want to make sure you keep a record of what's going on in your application. This from a runtime perspective doesn't really matter much, but if a user goes and installs a mod, that mod removes the base movement and then the mod's movement system breaks, they'll blame the game before they blame the mod. And what we can do is go into the log and go, hey, this mod overridden our movement. You should go see it and make sure the author hasn't screwed something up. Really simple stuff. And then we have another thing right here, so we need to go public, static, action, and then we just go get, and then string key, and tell that you decided to hit enter on me by default. So go action map.get and then key. Luckily, in the newer versions of Java or whatever it implements hash map, I'm pretty sure it's Java, you can just call get. It used to be you had to call actions.contains, and then actually we'll go ahead and do that. We'll call action map.contains, and then it's an extra check that doesn't really matter. A lot of people are like, oh, but if you do a contains check, it slows your thing down. It actually doesn't. Hash maps are beautifully performant-wise. What happens in a hash map is I take this key and I turn it into a number. That number then has a position in an array, and what this does is it goes, okay, find my position in an array, and if I have that position in the array, then I am contained. Then the get calls the same way. There's no difference. The only time that this is not this way is if I have multiple objects stored that have the same hash ID, which is really rare. In that case, then it pulls back a list of objects because what it does is it's got a bucket system. So imagine a bucket, and that bucket then has an ID of like number 1, and the next one next to it has 2 and 3 and 4. So in bucket 1, we can have more than one object if we accidentally have multiple hash keys. Then you just take that bucket, you bring it back and go, okay, does this one equal the object I'm looking for, or does this one equal the object for what I'm looking for? If you can't answer yes on either one, you return the first entry, and then you return it back, and it works out pretty good. I've actually implemented hash maps and maps from scratch before, thanks to a couple of classes I've taken at the university I'm at. This is the reason why I actually know how they work now, and I gotta admit, they're pretty beautiful pieces of technology. But we're gonna go ahead and document these real quick. Adds an action to the map of actions for entities to use, and then we're gonna go gets an action by its string ID. That's all we need to do, some really quick note of what these are. And that looks good. So now we just need to register our actions in some place. You know, we finally need to start getting like the game logic here separated from the render logic. So we're gonna go and close everything else, and we're gonna start, I guess, initializing things. So public, how do we do this? Protected, void init. So when we click run, first thing we need to do is run init. So that's the first thing needs to run. And in init, we need to call tiles.load. Then we want to start registering actions. Register actions. So then we would go action dot add action, new action, move. Register that. We want to go over to how to do this. So we got our game display here. This is where we've kind of messed up. We don't have a separation between these two layers. Okay, what we need to do is we need to copy this. This needs to go in our init call. So we're going to load our map. This is our map. Create a test map. So we're going to go get world, and then we're just going to set data here. So this will load our entities. Which means we don't need any of this stuff. We actually don't need this entire method here. We're going to copy this part though. We're going to remove this. Okay, we have a main method here somewhere. Right here it is. Our main method actually comes preloaded with a load argument thing. I copied this from one of my other applications back when I first started this project. Because that's the thing, I've only been recording this for a while, and I only said I've been spending so many days. The reality of it is that here several months ago, I started on this project. I built up basic data. So I built up a main method, I built up some entity classes, some inventory classes, and then I lost interest because nobody seemed to really care that I was working on the game. Nobody seemed to be interested because I didn't have graphics. I completely neglect this almost every time I work on a project, that people only care about what they can see. If you tell them that you built this amazing algorithm, and this algorithm could solve like cancer, for example, they wouldn't care unless you could show them it solved cancer. And that's pretty much how it works. Same way with games, it could be anything, business applications. You could say you've done something, and I've put some impressive code in here, like the inventory code is actually finished. It is usable, but because I can't apply it to an entity right now, I can't show that the inventory code works. I can show tests because we have JUnit tests down here. If I open these up, we have tests that show that certain parts of these work. Like we have the TAC code is tested out, so we know it works. Inventory code is tested out, so we know that it works. Pretty much. So we're going to go in here. So we've loaded our arguments. We need to run a game display. And then we need to create a game. So game equals new game. And then we want to run them both pretty much. I believe these are both threads. Oh, it's a runnable. Okay, calling start on here will run it. Okay, so we don't have to worry about that. Do we want to do the same thing with our game loop? Display. So we're going to call this display loop. Display graphics is what we're going to call this. And we'll call it game graphics just to be consistent. And then we want to, wherever our game went to, the game's, the code's already getting so large and I'm having trouble navigating it. Okay, so we do want to extend this to runnable. Or implements runnable. And then what we'll do is we'll go ahead and we'll copy this code real quick. And we just need to create a thread. So private thread. and this will be game logic. We'll have both of those guys. We just need to go back to our main method. So we got our game. Then we want to go game.start. Actually, we want to start these after we've initialized everything. So we create our display. So create display. Then we want to go to do check if server only. Create game. Then we want to start the game, then start the display. Start threads. I don't know if we want to do something here. The odd thing is we're using system.out and stuff. We have a logger. We actually do have a logger here, and I should be using this, and I'm not. I'm going to put this at the bottom. Call this end of main. Okay, so we'll go here, creating game. So creating game object. We'll go here, creating display object, and then we'll go here, starting threads. Actually, we wouldn't put this before system.exit because if we don't, it'll run system.exit. We won't see that line run. And we're not going to do anything with the launch arguments yet because we're not passing any launch arguments in. What the launch arguments would be is we would check to see if we're a server only, if we're a client, what is the IP we're connecting to, various things. I might make an external program to actually handle the server stuff. So what you would have is you have an external launcher. You go, okay, I want to see what games I connect to. I then want to connect to the game, and what it'll do is it'll launch the game with the connection arguments, etc., etc. It'll actually ping the server real quick before it launches, just to make sure that the information provided is actually going to run. But we got all that. Let's run it real quick and see what happens. We now have a big issue here, though. We are now a threaded application, which means we have more than one thread, which means there is a possibility at some point in time we're going to have an issue. And okay, system.exit ends up being called. But the rest of our stuff didn't run. Is there a start and a wait call for threads? So there's a start call. There's a run. I know how to actually make this work. I just gotta give me a second here. Okay, so we need to make these two public. So public. And then same thing up here. Somewhere in here there's those two objects too. So public, and then public. And then what we're going to do in the main program here, we're going to go while I guess literally like this. Display is running, or game dot is running. We're then going to go thread dot sleep. And we're going to sleep for a second because I don't really care. I guess we got to put a try catcher on this. You know, actually we don't. We can cheat real quick. That'll work. And then what we want to do is right before we sleep, we want to go, okay, if display dot is not running, then we want to go game dot running equals false, and then we want to go game dot save true. I want to make sure the game saves it. Like, no matter what you do, so if I click the exit button at the very top corner, this game should save. Like, whatever state it's in, it should save it. And it should save it as always in an autosave. So say I'm a user and I just hated whatever situation would just happen. Like, I lost my main character and I clicked X and it closed. I don't want to save over his main save because he may want to just reload the main save. But I do want to give him an autosave in case he decides to come back after an hour and go, I think I was a little bit harsh on the game. Let's reload that save and I'll play it out with my main character dead. I gave him his autosave, so he can reload the game. Given there is no save code, if we actually open here, there's like squat. There's squat for load code too. But we'll get to that point here in a bit. And by a bit, I mean later. So now we got to figure out what's going on with me not getting any thread debug out of any other spot of the game. So we're going to run main again. Null point in game logic loop, and then null point in get world. We're gonna do this. We're gonna move this line. Where's this being called at? Find usage. No usage in project? Okay. Okay, so we're gonna make a method here. Or actually, we're gonna make a constructor, public game, and we're just gonna make sure that's always initialized until we get to a point where we have a loading screen and stuff. So we're gonna stop, and we're gonna hit run. Cool. We have our stuff. We need to add another counter here. So we need to actually check how quickly our main game loop is running. Because we have our frames per second, our updates per second according to the render code. So there's an updates for the render code, there's a frames per render code. Then there's an update for the game itself. And the update for the game itself will be ticks per second. Because we want to be at 60 frames per second no matter what. I'm not going to give you guys like 120 frames per second because this is a 2D game, and the reality of it, I might drop it to 30 just because there's no point in rendering as fast as I'm rendering. I then also want to make sure the updates per second are always 60 because all of our logic right now depends. Well, actually, our logic doesn't even care if it's that quick. The reality of it is I might actually switch the update logic to go as fast as the frame rates because all of our update logic is render logic right now. And control logic, and this, actually I can show off what's going on in my head real quick when I'm thinking of a reason of doing this, is if we open the game up, if I hold shift and drag, you see how choppy this is? It's not smooth. It's not a smooth movement, and that has a little bit to do with the fact that we only check 60 times a second where the mouse is, and it means we're not going to move as quickly and as fast. And if I freeload the update logic, like I let the update logic go as quickly as it possibly ever wants to go, then we get much smoother controls. I can let the frame rate logic go that high too, although that will probably tank your graphics card. Because then you'd be running as many frames as your graphics card could possibly hold, and like I can hear mine right now revving up pretty high. If I actually go to my resources, we can see what's going on here. OBS is the main reason why my stuff is actually running hot. But let's run the game real quick. I actually want to check to see how the game is doing on CPU and RAM since we've been working on it. Yeah, see, we actually have a decent RAM usage here, or CPU usage on the game already from this update logic. Because even though I'm running a graphics-based game, majority of those graphics are still running on the CPU. We're only running the actual geometry render logic on the graphics card. So when we go to calculate where the geometry goes, that's calculated on the CPU. Eventually I'll transition this all to the graphics card once I figure out what shaders actually work and how they are meant to behave, and then this will go down a bit more. But then you'll have to worry about your graphics card, and I actually have no way of measuring my performance on that stuff. So yeah, I'm gonna have to figure out how to do that because that's actually important. Because even though I've got a really nice graphics card, I think my graphics card's got like 8 gigabytes of RAM, and it's got I don't know how many small little GPUs in it, but yeah, we'll move back to what we're doing. So this logic's running. So we know anytime you kill the display, then we want to kill everything else. And then we want to do the same thing if we kill the game loop here. So if game is running, then we want to go display running equals false. So we just want to make sure that no matter what happens, if we click anything, the game kills off. We don't leave threads running. If we leave threads running, it's bad. And then what we do with this while loop is we're just checking every second. And we put thread.sleep in here because if you do not put thread.sleep in here, this loop will never exit. I actually have built applications without this sleep thread, and it took me a while to catch on what was going on. The while loop runs so fast on the CPU because it literally runs in under nanoseconds that it does not have enough time to wait on the other thread to do something before it does something. This means that it just never will update. I wrote a launcher for a client that had a while loop in it that checked to see if the download process was done for a mod pack for Minecraft, and it just kept looping and looping and looping and looping and looping and looping, and it never stopped. So I ended up fixing that by putting a sleep thread. Now his I did 300 milliseconds. This I'm going to do just a second. The reason I do 300 is because the average reaction time of a human is somewhere between 100 and 300, and that means no matter what you do, you're not going to usually have input that is faster than that, and even if there is input that's faster than that from a person, they're mentally not going to react in time to really make a difference. So if I made a display that showed up and I was checking every 100 milliseconds to see if that display closed, that's not closing any faster or slower. As long as I'm between the 100 and 300, the user is not going to notice. He'll still think it's instantaneous. It's an important thing to keep in mind when you're designing things, is that that is actually a thing. But this is all good. We can now start running logic pretty much. So we can move all of our game logic to our game, which we don't really have any right now. But what we're going to do is we're going to come down to our update loop. Update, 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 update. I guess running is our update loop. We want to do exactly what this is doing right here. We're just going to literally copy this whole set here, and we're just going to delete what we don't need. So we don't need the mouse server side. We do need an update method. We do need a tracker update. We do not need to render. We do not need to check any of this stuff. We do need to track how often we're updating. We don't need this. We'll make our own version of that here in a bit. We're going to go public void update, and then we want float delta. And I butchered the word update. Here we go. I have indeed had coffee today, just as a note. I, however, ended up spending 2 hours looking for a W-2 for a job I had, and pretty much burnt myself out of physical energy, and it might be a little bit before I get that back. Okay, so one of these is private, one of these is public. We want the update to be private, and we want the previous update to be public, because we're going to access the previous updates from our other loop. So this is going to run. Here's our update loop. And here is where we actually want to start updating our entities. So previously what we were doing to update entities is we're putting right here. This is actually going to be taken now, and this is going to be put over here. And very quick. So we're updating all of our entities. Anything else in here that could be server-side logic? We don't want to do controls. These are client-side. We will move all of our controls out to a separate object here. Just because they're in the way, and we need to be able to differentiate between editor controls and gameplay controls. As I noted, I want to break my game display down into a prefab. One of the reasons I want to break it in prefab is it cleans up this class, makes it easier to read. But on top of that, I do actually plan to make more games in the future. And if I can put all of my pre-built logic in its own little engine folder, and then build the game on top of that, I can take my engine, take it to another game, continue working on the engine in the other game, come back to this game, update it, and then keep working on other things. I do want to have a solid Java game engine I can play with that isn't built by somebody else. Because everybody has their own way of doing things, and I've found over time, especially with messing with things like Unity, Unreal Engine, a few of the other ones that are skipping my brain today. I'm trying to remember what, because I know there's the Unreal, there's the Unity, there's the one they built. Oh yeah, the Cry engine. I have played with that. There's a couple ones. There's one my buddy Maxwell uses. I need to stop using the word buddy because it's been less of a buddy thing recently. We're more of colleagues now. He uses his own engine, which is built by some guy in Russia. I forget the name of the engine. It's actually not bad. I actually built a little prototype in it once. There's another one my buddy Z uses. It's a C++ engine. I actually almost built games in that one. It wasn't too bad, and I can actually code in C++. I can't code in C because I'm not used to that memory management model. C++ does, I believe, have a garbage collector in it. I don't recall. It's been 3 years, so I could be wrong on that one. Anyways, moving on. I want to build a game engine to build Java games on because Java does run well. People give it crap and say like, oh, you can't build high-performing games in here. You actually can. You just need to think outside the box. We're using OpenGL to render with. OpenGL is actually written in C. And then what we're doing is we have a Java thing that communicates from Java to C and back and forth. If you build a high-performant game, you can do the same exact thing with other things. Like say you want to access some form of native a little better. You want to maybe use your internet card better. You could write natives to do that. And it's the same ideal as you'd be writing that game in C normally. The reason I'm using Java is Java cleans up after itself pretty well. It's really easy to understand. The object behavior lets you build up games quickly, where if you did C, you would have to build everything through function calls. So really how C works is that think of making a chain, and then every link in the chain is a different function call. So when you build your game, it's just a huge chain that is always going in the same order. You can put switch statements so you've got little chains that branch off from each other, but you always come back to the main chain. Technically, Java is this way, but you can make those links, and a link could be thousands of small little chains built together that then all you can do is put it in, pull it out, and you can recycle your code much, much easier. C does have header files, which allows you to recycle your code, which I do have to admit is pretty cool. I wish Java had that feature. Interface is the same equivalency, but with C, I can build a header file. Then I can build the implementation code. I can leave the implementation code somewhere, import the header file. C will then go, hey, I know where your implementation is, and will auto import for you, and then you can use it anywhere. You can't do that in Java unless you build your own version of it. So it's always important, I guess, to recognize the advantages of technology of different languages. Well, I got off on a little tangent here. Render code, GUIs. We don't want to be updating GUIs in our server logic. I think we're good. I think updates was about the only thing we really needed to do. We do need to update our tiles too, but we'll come up with a better way of doing that. Minecraft and Forge both update their tile logic by having an array of entities, just like I do, and I think I'm just going to keep with that because as long as we stay under a couple thousand entities, the game will run well. As soon as we get up too high, and Minecraft has the same problem, and you get up too high, your game cripples. I think Minecraft's limit is about 100,000 entities that do not have collision boxes and about 1,000 entities that do have collision boxes. As soon as you throw collision boxes into any game, you immediately start to tank the game because of the fact that checking collision takes time. No matter what you do, it takes time. Now, in Minecraft's case, its collision logic is actually pretty simplistic, but you still get the problem that things collide, they detect collision, they push each other out, then they apply motion to each other. By applying motion, they push each other into each other's collision boxes. When you push each other into collision boxes, you have to recheck collision and you reapply all the movement. That's the reason why Minecraft tanks after a certain while. It's actually not the collision logic per se. It's a combination of all the factors that come together. And I'm avoiding that in my game altogether by not even using collision logic to start with. Then again, I say that and I want to put tanks in here, and tanks will require collision logic because they'll be able to rotate, which means their bounding box will not be in the same place all the time. So I'll have to put some better stuff in here. But we got our game loop now, and I'm happy about that because I was worried about making this game all the way from top to down, and not doing anything. But let's move back to action. So we got character. We've already added the action thing here. So we're gonna make a method for this, I think. Yeah, public void init, just so we clean up some of this. And then we're just gonna call init from here for the moment. Yeah, that should work. We have a controller object here. This is unfortunately the controller logic is actually something that would be used client side more. Right now it doesn't have any data in here, but this is what it will actually be used to control the entity, I guess. The reality of it, I don't know what I'm going to stick in this class. I need this object just simply to tell who has ownership of what entities, who's currently in control, and et cetera, et cetera. But I don't know what else to put in there. So, but we got the movement here. Then we need to go to our game GUI. We also need to initialize controllers. There's quite a few things I need to do to actually start to properly get our game rolling. Because we've been doing everything in the graphics object, and that's cool, but I now need to kind of diverge off of that. Okay, we'll go back to here. We got our init. We need to set our controllers. Set controller. So we need to make a player object. Player equals new player. Character entity. We're gonna get rid of that. We're definitely gonna get rid of all this. I don't need this anymore. Get rid of this. Okay. Yep, get rid of that. Cool. That was logic from one of the earlier episodes I did where we could move around freely. But we're gonna do this. We're gonna set every character we spawn really quick as the player, and then we just need to return character on this. So return this. This will just kind of help us chain method call like we're doing right now, where I can go create character, set controller, set position, and it just makes life a little easier when spawning characters. Okay. We're going to actually create this up here. The reason we're going to do this is actually, there will always be somebody in control of any given game. So we have a game, you're going to have a game per client, and then you have one per server. The server will be a player controller because he will be controlled by a game master. The game master will log in with a client. His client will then take control of the player object. So we've got this, and we're going to just, in the game loop, we're going to set this, because we're going to set this to something later, but we're going to just globally have the object there. And so we're going to set player, and then what we want to do is I want to create some enemies. So I'm going to go for int I equals 0. I is less than 20, I plus plus. We then want to create some kind of random. Yeah, we're just going to create a random in here. So public final random equals new random. I feel like I've already got, you know what, hold on, I think I got a random object stored somewhere already. Wow, that's written in. Yeah, you can tell how long it's been since coding lib's been used, that it's compiled in Java 7. I actually want it to be compiled in a lower form here later. Let's see. I need to add the documentation of this. This dot roll between this dot roll. Roll calls dice roller dot random. Okay, so dice roller just has its own random. Okay, so we don't want to worry about that then. So we'll just make it random, and I want to randomly place a whole bunch of characters. So int x equals. Actually, do I have a math.rand? I do. Or actually, no, that's a Java. That's a Java class. But that does give me a random number. That's not what we want though. So we want to go random dot next float. Or actually, we can do next int. It's literally the same thing as next float, but it does the work for you. So we want to go our between 20 and negative 20 is where we want to be. Actually, we do it this way. So yeah, that should work. And if we repeat that, then we can place characters around. So here's our y value, and we're going to set this. Actually, we're going to go while some number. Actually, we'll do it this way. So we need another number here because we want to make sure we actually place 20 characters, but we don't want to loop too many times. So with our random number generator, there's a chance that we can randomly generate the same number multiple times in a row, and we don't want to stack characters on top of each other because that's the reason why we actually spread characters out here. So we want to go get world.get entity x, y, and then 0 because we're on the first floor. If this equals null, then we want to go get world get entities.add, and we're just going to copy this code real quick. We're not going to set this to the player controller because these are AIs. We will come back and we will make an AI controller here later. That way the AI can move around, and we're going to set this to x, y, and then 0. And then we're going to hit break to break out of the current loop, so that way we go to the next entity, and this will have entity spawned. And the reason we're doing this real quick is I'm going to visually test to see if the controller is working, and how we're going to visually test to see if the controller is working is we're going to go down to our render method down here for our entities, and we're going to have two character renders. So we need another character render object. The character render object will eventually be replaced with the same thing we use for the tiles. The tiles all have their own renders. Characters will all have their own renders. Although the character system will recycle the meshes, because I need to do this for the tile system. Tile systems all don't share meshes either, and that's kind of a poor choice because if we get 32,000, say if we've actually somehow managed to get 32,000 tiles, each mesh takes up, I'm trying to think of what the number is. So we have vertices. Each vertice is, I believe, a 3-coordinate system. We have 6 vertices. So I'm going to times it by 6, times this by 3, times this by 8. Yeah, so we're using 4.6 megabytes worth of RAM in the GPU. That's just for the mesh data. This isn't including the textures. This isn't including the UVs. This is including like anything else. And that's just for tiles. It doesn't sound like much, but I want this game to run under 100 megabytes of RAM on the runtime, and then have less than 500 in the graphics card. That way anybody can load this game up and without any problems. And actually the graphics card I want to get down even lower because I want to put this on a cell phone, and cell phones don't have graphics memory, so that means any memory you use on the graphics card will be translated over to the cell phone's RAM usage. Cell phones have somewhere between half a gig to 2 gigs usually on average, and that means I want to shoot for that half a gig. So I want the whole game to use 500 megabytes of RAM or less. But get the character render too. We got to come down here. We got to create it somewhere. All of this render object data, which we are creating in our init method, I am going to translate all of this over to a different segmented code. And I believe I already have a character for this. I gotta switch to project view. Resources, textures. Yeah, there's char too. Okay. That saves me some effort. And yeah, he renders on the same layers, so there's nothing that changes about him. And we come back down to our doRender call. And right here we want to go if character, no, we want to go if entity dot entity's instance of character. And entity dot, is there no way to get the controller? Controller is a protected method, so we want to come down here and we would go public controller. We just want to call this controller because it's a direct access. It's not like a get call. It's literally this is the controller. This isn't exactly Java standard to do it this way. Usually Java standard says it needs to be called get because you're grabbing or you're getting something, and then the name of the object. And then if you're calculating, it needs to be calculate, or if it's like find, or you name your stuff basically by the action you're doing. But if I know I'm just creating a direct pass-through for an object, I usually call it this because then there's nothing in here. I reserve get calls for things that actually may change slightly between each call. And not between each call, but between each time, because how your calls should be designed is if I call your method like 1,000 times, it should return the same result 1,000 times until you come to the next cycle. And the next cycle of the logic loop, then you can change it because then the next 1,000 calls will still be the same thing, but you've changed your data because you've changed your logic. Moving on. Put this here, controller equals game.player. We want to render the default render. If it is something completely else, we want to render something completely else. So we want to render controller 2. And if we run our game, hopefully we don't crash. Okay. Yeah, I created an AI class even though I didn't need it. Look at that. That is cool. We're going to screenshot this. And yeah, that's cool. Now, I think I said I was going to get buttons to work. I'm actually going to do that in the next video because I'm going to go ahead and take a break and go play games with my buddies, and then I'll come back. So we'll cut this video and I'll see you guys later.